All right, today we're talking about multiplying fractions. So, one of the big rules, again, in anything that we talk about multiplication is that I can multiply anything together, right? So it doesn't matter if I'm multiplying numbers or if I'm multiplying variables. It doesn't matter if I'm multiplying numbers and variables. It just doesn't matter because we can multiply anything together. That's what we got to remember. Remember that there's all different ways of doing multiplication with variables, or at least showing it. Remember, I can, if it's a variable and a number or two variables, I can just put them together and it shows multiplication. I could use the dot. I can still use the X. I can use parentheses. Right? All those show us that we're doing multiplication. The other thing that we have to think about is when I'm multiplying, we got to think about the sign for our answer. So again, if we have two or more numbers and they have different signs, if we have two numbers and they have different signs, one positive and one negative, my answer is always what? Negative. If I have two numbers and they're both positive or both negative, my answer is positive. Okay, so those are things that we've talked about a lot throughout a couple chapters. And so we're going to use all those rules. So, first things first. When I'm going to multiply, the first thing that I can always do in multiplying fractions is try to reduce. What directions can I reduce in? So, either diagonal or what else? So I'm looking diagonal. What's the other way? This one you probably...
Up and down.
Yeah, this one you probably wouldn't do it so much because they would give the problem to you most times. But when you talk about reducing up and down, this is probably actually more what you would do for number 3. Okay? If you decided to multiply first instead of reducing first. But I can multiply or reduce in either of those things. Once I figured out if I wanted to do and did my reducing, number 2 thing that I would do is multiply. When I multiply fractions, how do I multiply? Straight across. Now, this is one thing that we have to make sure of, is that when I multiply straight across, I'm going to do both the numerator and the denominator. So that means I like to show this by putting arrows across the top and across the bottom. So I remind myself that I'm going to do it both on the top and the bottom. This is a huge thing that we have to kind of get into our melon, because when we get into adding and subtraction, which will be the next couple sections later on in the chapter, then you only do the numerators or the top numbers. Okay? And so then at the end, I would also look to reduce again. Maybe I didn't get all of my reducing done in my first step that I did. Maybe I only did one diagonal instead of both diagonals. Maybe I just multiplied straight across right away, so I skipped step 1 and went straight to step 2. Then in step 3, I want to definitely make sure that I reduce. So take that fraction and just put it down, all right? So in our case right here, could I reduce either of the diagonals or up and down?
Yes.
No.
No. Like that.
So, if I multiply straight across, what do I get in this one? 3 over 10. So, that would have been my answer. Then the very last thing is, I should look at if I can reduce that again, but it's all already done. Okay? So, a couple things that we want to talk about though. If you have a whole number, I can make a whole number into a fraction by simply doing what to it? What? Yes. But over 1. So if they give me 21, I'm going to make it into a fraction as 21 over 1. I guess in the proper, that would be all right. Okay? Yeah. The other thing is that if I'm given a mixed number, Before I try to reduce, before I try to do my multiplication, I want to turn into an improper fraction. Do not try to simplify or to multiply with a mixed number. So again, if we had 2 3/7, how do I change that into an improper fraction?
2 times 7 and 3 over 7.
So what's 7 times 2?
14.
Plus 3?
17 over 7.
And then we always put it over our original denominator. So again, I'm going to use 17/7 in my problem, not 2 3/7. If you try to do those things in the problem, it will affect it a little bit. Or actually a lot of it. So make sure you turn it into this first. And then the last thing, we've said this more than one time, but one negative is for the whole fraction. So if we had -7/8, we could put it kind of out in front, or we could put it on the top, or we could put it on the bottom, but those three fractions all mean the exact same thing with one negative sign. Again, now, personally, I would go ahead and try to write it as one of the last two options. Put that negative either on the top or the bottom, just so you don't get confused, because sometimes when people start going really fast in the problems and they just have one negative and it's basically right off of my fraction bar, then they kind of say, well, maybe it should go to -7 and -8. But that's not the case. So again, I would recommend putting it either on the top or the bottom. All right? Any questions with any of that? So again, like I said, the last few things that are up there are really things that we've talked about before. So hopefully it didn't really bother you. So my first problem is 2/5 times 5/8. So the first thing I ask myself is, can I reduce?
Yes.
Yes. So again, maybe some of you are just going to try to multiply and then reduce at the end. That's totally fine. What you got to be careful of though is what? If I'm going to multiply right away, some of my fractions at the end might actually be pretty big, the numbers involved. And so then, like when we did 304 over 100, we didn't really reduce that very easily because the numbers were so big. You got to take that into consideration. Okay? The other thing is that when you start doing these kind of problems and you start crossing things out for your reducing, just don't lose anything. All right? Make sure you understand how you cross things out and what's left over. Don't lose anything and don't forget anything. All right? So you might have to really take the time to understand how you're going to do some of those things. Again, I understand how I reduce or cross things out. You probably understand your own method, but I might not necessarily understand yours all the time, and you might not always understand mine. So just be careful. So in this case right here, I can do my 5s. And again, my way, I'm not even going to put a 1 in there. Now you can always put a 1 because remember, when we're reducing, we're basically dividing, right? So there are 1s there. And then can I do 2 and 8?
Yes.
Sure. And so what's left over?
1/4.
Do I need the 1 on the top? Yes, I definitely need the 1 on the top. I don't always have to have a 1 on the bottom. Okay? Bless you. On the second one, let's just say that we went right to the multiplication because we were in a hurry and we want to get done with our assignment. Not that any of you would ever hurry. But if we just went and did the problem as 2 over 28, then this is where you really got to go back and do step number 3, which says go back and reduce. So make sure that I come back and say that I can take 2 out of both, so I get -1 over 14. Now again, I could have done that here by crossing things out, and I would have had -1 times 1, which is -1, and 2 times 7, which still is my 14. Okay? So, next problem, we want to show this one because they have mixed numbers. So the first thing I'm going to do is what?
Make them improper.
So what's 1 1/2 as an improper fraction?
3/2.
And what's 3 2/3?
11/3.
11/3. 8. Okay? So my 3's cancel out, and my answer is
11/2.
11 halves, right? And again, try to leave it as an improper fraction. We would much rather have 11 halves as my answer instead of 5 1/2. Now, if you turn it into 5 1/2, will it ever be counted wrong? Heck no. But it's just going to be easier if you do it, leave it as an improper fraction. Any problems with any of those? We have 7 times 8/21. So again, this is how they might write this problem. But again, because it's a whole number, I can always take it and turn it into a fraction by putting it over 1. And now I'm ready to go back to work, right? So now I reduce, and I end up with
8/3.
8/3. And again, I'm going to leave it as 8/3. Okay? Any questions there? One last one. If we have negative 5 1/3 times negative 3 3/8, when you start writing these problems right here, if you would forget to use these parentheses, it might turn, or look, as you turn it into a subtraction problem, so make sure you put the parentheses in there. And then the other thing, the reason I want to show you this one is if I'm going to do this problem right here, I want to make sure that I turn it into an improper fraction still. But when I do that and there's negatives, don't use the negative as a part of that transformation. It's still just 5 times 3 plus 1. It's not 3 times negative 5 plus 1. Because it would change the problem a lot. Okay? You want to finish this problem?
Sure. I
Go
know.
ahead.
45/4.
45 and 4. Anybody else?
Is that for just one or is that for? That's all it is.
We should have got 16/3 times 27/8,
I couldn't read my writing.
right?
8 out of 10 right here. 9.
So 8, 2, 3, 9. 9 times 2.
18/.
Should have just got 18.
I told you. 9.
So again, this is a good comment right here, right? He said I couldn't even read my own writing. That's where you got to be careful. And again, look at my chicken scratches. I understand that.
45.
But that might totally be different for some of you looking at this. So just make sure you understand how you're going to cross things out and make it so you don't lose anything at the end. Any questions here? The last thing that we want to show is when we're dealing with variables. So again, we showed different ways here of writing the variables as multiplication. Again, look at this first one right here. Can everybody tell that that is k times y? Maybe, maybe not. Maybe that means an x as a variable to some of you. So just be careful of using that one. But then we could put it, one of them in parentheses if you wanted. We can just write them next to each other. It doesn't matter really the order, but we would like that it's in alphabetical order. Okay, so just remember all that stuff. Basically though, we're doing the exact same thing with variables, right? So if I have variables, remember, anything with an exponent I can rewrite. So k cubed is just basically k times k times k. And so what does that really mean? I'm looking up and down to see if I can cancel them out. So I can do the same exact way of reducing, up and down or diagonally with variables. That doesn't matter. All right, so again, keep it basically doing the exact same thing, and we'll try it out with some variables. So, first problem. 3p squared all over q times, I'm going to change it here, q cubed over r. What about that? Okay. So again now, we're still looking to reduce first, either diagonally or up and down. Now here in these kind of problems where we have terms instead of just numbers, we might actually have a little bit more of this up and down reducing, but maybe not. So can I take something out of somewhere?
Q to,
Yeah, so I'm gonna do my Q's. Now here again, I emphasize, don't lose anything. Make sure you write it so you can read it in your own writing, right? Notice I'm gonna take one of these Q's out. Well, one of these Q's means the whole thing down there. If I take one of these, now again, this is totally how you're going to do it. I myself just do this. Maybe you don't like it that way. Maybe you want to rewrite it and show yourself that it's Q squared. Now, that's totally up to you. Okay? Can I do anything else? No, right? So now I'm ready to multiply straight across the top and straight across the bottom. So on the top, what do I get for my answer?
Q, or 3p squared and times q squared.
All over?
R.
Agreed? Now again, if everything would have got canceled out on the bottom, do I need to put a 1 on the bottom? No. If everything gets canceled out on the top, do I need a 1 on the top?
yes.
I have to have a 1 on the top. Okay? Let's try another one. You guys try this one over yourself. I'm going to switch it up from what's up there. Let's say 4g to the 5th all over 9r cubed times 18r to the 4th all over g squared. Try it out. See what you get.
So trick question,
Yes, sir.
it's a trick question.
This is? Or you have a trick question?
No, like, I got an idea what to do, but I don't know if it's
You have a idea how to solve the trick question. Chance, you still got a quiz or test in here to make up too.
For test?
Yes. In chapter 4,
Or is it a quiz?
there was a test.
Okay.
Make sure you get that done sometime soon. What's your question?
I think I got it. If I got the right on an actual genius. I don't know if I got it.
Actual genius? All right, let's see.
If I got
I'm going to take all 3 of those, and I'm going to take all 3 out of 4 of those. I'm going to take all of those, so this becomes a 3. I'm going to turn this into a 1 and this into a 2. So I'm going to get 8g cubed r. That's what I get.
Yes.
Yes.
Let's go.
So here's a great example right now of looking at it, and you know, if you're going really fast, this right here might not really look like g cubed anymore. So just be careful when you get to the end. Right? And why is there nothing on the bottom? Because there is nothing. We cancel everything out on the bottom. So there's a 1 there, and if you wanted to write this and put it as a fraction over 1, that's totally fine. We'll never count that wrong. Okay? Hold up now. Don't put things away yet. The last thing we talk about is dimensional analysis. Have you ever heard of that?
Dimensional analysis?
Dimensional analysis. A dimensional analysis might be more of a science thing to you. Basically taking one label and another label and either putting them together or separating them and getting a new label. Okay, so you might do this in science, but you're probably, if you're going to deal with dimensional analysis, you're probably dealing with story problems. Okay, so read the second story problem here. A car travels 65 miles per hour for 3.5 hours. How far did it go? We want you to use D equals RT. So what does, first off, D equal RT mean? Distance equals rate times time. And what's a rate?
Distance travel.
A speed, right? A speed. Okay, so we could have, in this case, miles per hour, we could have meters per second, you guys were talking about that with gravity the other day, right? You could have feet per second, kilometers per hour, or whatever. So, if I did this now, what you have to realize is what numbers go where. So I'm going to use D equals RT, and from our paragraph, what does it mean when it says a car travels 65 miles per hour? What letter does that represent? My R, right? So I'm going to say equals my R, which is 65, for 3.5 hours. So 3.5 is my what? My time. So remember, RT means that I'm multiplying, and then I'm looking for a distance. Now, what does 65, how is it shown in our problem? What rate is 65 represent?
Wait,
What rate?
Oh,
Miles per hour, right? And what was our time given to us in? Hours, right? So notice here, if I multiply those together, which I'm doing with my numbers, I'm actually multiplying those labels together. So when my labels get multiplied together, the hours are diagonal to each other, they get canceled out, and what's left over?
miles.
Miles. And what does it say? How far did it go? Is that represented in miles? Yeah. So, the first thing to do this problem is what?
Make it improper and put it up to 1.
3.5 as an improper fraction would be what?
6,
7 halves.
Put 6 on 1.
Now, 65 times 7. We would have 455 halves at the end. Now, in a story problem, if somebody said, hey, I just traveled 455 over 2 miles, would you really understand it? Maybe yes, maybe no, but so remember how we always say we should never turn this into a mixed number, or we should never use a decimal? When you're doing story problems, you can use those two things. So, punch it in your calculator, or figure it out what it is. So how much?
227.5
What?
miles.
Miles. So again, because it's a story problem, when we're talking about dimensional analysis, we're going to always have a label. Alright? Make sense?
Yeah. Yes, sir. Yeah.
Alright.